Welcome to AP Calculus 4.1b Homework Solutions. We're going to be on page 249 and go through all of these problems. So let's start with number 51. The instructions are to solve the differential equation, and we're given that f double prime of x is equal to 2. F prime of 2 is equal to 5, and then f of 2 is equal to 10. So we've been given f double prime of x. What we're trying to do is get to the original equation f of x. So we're going from f double prime of x, then we're going to integrate that to go to f prime of x, and then we're going to integrate that to get to f of x, which is going to be our answer. All right, so, and we're going to be able to use this information to solve for c during each successive integration. So we're going to start out f prime of x. We're going to integrate f double prime of x, which is just 2. Okay, so that is 2x plus c. All right, now we know that f prime of 2 is equal to 5. So that means 5, right? F prime of x is 5. 5 is equal to 2 times 2 plus c. So that's 5 is equal to 4 plus c, so c is equal to 1. So I can get our equation for f prime of x now. It's going to be 2x plus 1, right? 2x plus c, c is 1. So 2x plus 1. Now we can get f of x, go up a level by integrating f prime of x. So we're going to integrate 2x plus 1 dx. That's equal to x squared plus x plus c. We can get c because we know f of 2 is equal to 10. So 10 is equal to 2 squared plus 2. Remember, our y value is 10. Y and f of x are the same thing. Plus c. So 10 is equal to 4 plus 10 is equal to 6 plus c. So 6 has to equal 4. Excuse me, c has to equal 4. So f of x, and you could call it y also, but f of x then is equal to x squared plus x plus 4. We found c there. And that's our final answer. We went up 2 levels from the second derivative all the way to the original equation, f of x. All right. Let's do number 54. Okay, so 54 we have f double prime of x is equal to sine x. F prime of 0 is equal to 1. And f of 0 is equal to 6. Okay, so we're going to go up from f double prime of x to f prime of x. We'll go up 1 level. We're going to find that by integrating sine x. All right, that's going to be minus cosine x plus c. If you're not sure about that, the derivative of cosine is negative sine, so to get to positive sine, we'd have to put a negative out front. So now we can find c by using this information here. We have 1 is equal to negative cosine of 0 plus c. So that would be 1 is equal to cosine of 0 is 1. 1 is equal to negative 1 plus c. So c is equal to 2. So f prime of x is equal to minus cosine x plus 2. All right, let's go to f of x. So we've got minus cosine x plus 2 dx. So that's going to be sine x. It's actually going to be minus sine x, thinking about that. So the derivative of sine is cosine. The derivative of negative sine would be negative cosine plus 2x plus c. Now I have this information I can plug in. We'll have 6 is equal to negative sine of 0. Remember, that's x, that's y. Negative sine of 0 plus 2 times 0 plus c. Sine of 0 is 0, 2 times 0, so 6 is equal to c. So our final answer, we've solved the differential equation. F of x is equal to minus sine x plus 2x plus 6. All right, that does it for 54, solving differential equations. You may end up having to take 1 or even 2 classes in college that just focus on differential equations. So there's your initial taste of it. Okay, number 57. Now we're going to work those physics problems, the acceleration, velocity, and position problems. Starting with number 57. So looking at this, it says we're going to use A of t as minus 32 feet per second is acceleration. So a ball is thrown vertically upward from the ground with an initial velocity of 60 feet per second. How high will the ball go? So we have A of t is equal to minus 32. That's where we start. And we're going to go up a level. We know that V of t, to get that, we're going to integrate minus 32 with respect to t. So minus 30. So that would be minus 32t plus c. But in these problems, our c would be the initial velocity. Okay? So it says that our initial velocity is 60 feet per second. So v of t then, we have an equation for that. It's minus 32t plus 60. So we're probably going to need to use that in a little bit. But let's go ahead and find our position function. So to go up a level from v of t, we would integrate velocity with respect to t. So that's a minus 16t squared plus 60t plus our initial position s naught. Okay, so it says it's thrown from the ground. So because it's ground, s naught is just 0. So s of t, our position function, minus 16t squared plus 60t. So we have a velocity function. We have a position function. Now, what it asks for, what the question asks for, is how high did the ball go? Well, if it's thrown up vertically like that, so it's thrown up and then comes down, you might remember all the way back to chapter 2 that velocity is equal to 0 at maximum height. So we can figure out the time that it takes to get to a velocity of 0. So I'm just going to use the velocity equation and say 0 is equal to minus 32t plus 60. All right, so bring that 32t over to the left. 32t is equal to 60. So t is 60 over 32. right, so that's, what, a little under 2 seconds. At 1.875 seconds. So that's the time it takes to get to maximum height. But the question is, what is the maximum height? How high will the ball go? So we can get that by finding S of 1.875. So that's minus 16 times 1.875. Don't forget to square that, right? We're using this equation. Plus 60 times 1.875. So if you put that in your calculator and your calculator doesn't fail you, you should get 56.25 feet. All right, pretty cool. Kind of a puzzle there. It's amazing that we can just start from acceleration and answer these questions. All right. Okay, 59. I think 59 is probably the most difficult of these homework problems, but it's pretty cool. So with what initial velocity must an object be thrown upward to reach the top of the Washington Monument, which is about 550 feet? So again, we're starting with A of t is equal to minus 32. V of t is equal to, we're going to integrate minus 32. So that's going to be minus 32t plus our initial velocity. That's what we're solving for. So it's not 0, right? We're trying to figure that out. And then S of t, we would integrate minus 32t plus our initial velocity with respect to time. So that's minus 16t squared plus v naught t. And then we're throwing it upward from ground level. So S naught is 0. Okay, so we have this equation, minus 16t squared plus v naught t. All right, well, we know at max height, which is 550 feet, v of t is equal to 0. So we know then from this equation here that 0 is equal to minus 32t plus v naught. So v naught then is equal to 32t. I just moved that negative 32 over to the left. Now we can make a substitution. We can substitute 32t for v naught. Now we know our final position will be 550. We can set that equal to the position function minus 16t squared plus 32t, that's v naught, right, times t. So 550 is equal to minus 16t squared plus 32t squared. 550 then would be negative 16 plus 32, that's 16t squared. T squared will be 550 over 16. All right, and 550 over 16 is, let's see, $34.375. So t is equal to the square root of 34.375, which is 5.86 seconds. So that's how long it takes to reach the top. But that isn't the answer, is it? we want to know what initial velocity. So initial velocity is equal to 32 times t. So 32 times 5.86. All right, so that is 187.5 feet per second. So you have to use your substitution skills there. That happens all the time in math when solving word problems, needing to substitute. But this is a great problem to increase your understanding of how to work word problems. All right, 61. So 61, I'm going to try to remember to leave it on here because we will be using it to work some of the other problems. It says use a of t of negative 9.8 meters per second squared. In 61, we want to show that the height above the ground of an object thrown upward from the point s naught meters from the ground with an initial velocity of v naught meters per second is given by this function. Okay, so we're just going to start. This time we're in meters instead of feet, so we're starting with a of t is minus 9.8. So v of t, we would integrate minus 9.8, which is going to be minus 9.8t plus v naught. That's our c. And then s of t, we would integrate minus 9.8t plus v naught dt. The dt is important. So that's minus 4.9 t squared plus v naught t plus our c, which is s naught. Okay, so those are the steps. We're gonna use these in the next couple of problems. So let's look at 62. 62, Grand Canyon. The Grand Canyon is 1,600 meters deep, so that's about a mile at its deepest point. A rock is dropped from the rim above this point. Express the height of the rock as a function of time t in seconds. How long will it take the rock to hit the canyon floor? Okay, so how long will it take the rock to hit the canyon floor? So we know that S of t is 1,600 meters. Okay, so we would have 1,600 is equal to this equation. We know that the ground so S of t is equal to minus 4.9 t squared. We could do it the way I just said it, but it'd be easier to visualize it this way I'm about to do. So v naught t. Now our initial velocity, we're not throwing the rock down, we're just dropping it. Okay, so initial velocity is 0. And then our initial position, S naught, is 1,600. It'll be easier to think of it this way. So we have S of t is equal to minus 4.9 t squared plus 1,600. Now at the canyon floor, what is the position? The position is 0. So we have 0 is equal to minus 4.9 t squared plus 1,600. Now I can move that 4.9 t squared to the left to make it positive. So t squared is 1,600 over 4.9. All right, let's see if I have that written down. That would be 326.5. So t is equal to the square root of 326.5, which is 18.07 seconds. All right, and that answers the question, how long? And that, to me, that's very, very interesting. I mean, it just shows you how far the floor of the Grand Canyon is away. 18 seconds, if you're just counting 1001, 1002, 1003, seems like forever that thing would be falling, right? Okay, 63 says a baseball is thrown upward from ground level with a velocity of 10 meters per second. Determine its maximum height. Okay, so we have a velocity equation. V of t is equal to minus 9.8 t, and our initial velocity is 10. So plus 10. And then we know S of t is minus 4.9 t squared, so I'm integrating. In fact, let me write that out. I'm going to integrate V of t. Or you could just look up here, but it's going to be minus 4.9 t squared plus 10t. And the problem says that the baseball is thrown from ground level, so plus S naught, which is 0. Okay, we want to determine maximum height. Well, we know that V of t is equal to 0 at max height. So we can say 0 is equal to negative 9.8 t plus 10. So 10 is equal to 9.8 t. T is just a little bit over 1, right? So this it's 1.02 seconds. So that's the time it takes to get to maximum height. Max height is S of 1.02, which would be minus 4.9 times 1.02 squared plus 10 times 1.02. I'm just plugging the time it took to get to maximum height right in here. And that is 5.1 meters, which is not, that's, what, about 16 feet or something? So that's not very tall, and the reason it didn't go very far is because they didn't throw it very fast. All right, 10 meters per second is not very fast. Okay, so that does it for 63. We've got two more. All right, 65. So 65 is about lunar gravity. It says the acceleration due to gravity on the moon is negative 1.6. And we want to know, a stone is dropped from a cliff on the moon, hits the surface 20 seconds later. How far did it fall and what was its velocity at impact? So we're going to go through the same process here. V of t, we're going to integrate minus 1.6 dt. And that's going to be minus 1.6 t plus our initial velocity. But it says we're just dropping it from a cliff. We're not throwing it down. So that's 0. And then S of t will integrate minus 1.6 t dt. So that's going to be minus 0.8 t squared plus S naught, which we are trying to find. Okay, how far did it fall? What's our initial position? Okay, so we know it fell for 20 seconds. So, and we know that ground level, S of t, would be 0. So that's at the ground, or the lunar surface. All right, so we're setting 0 equal to minus 0.8 t squared plus our initial position. So moving that minus 0.8 t squared to the left, we would have positive 0.8 t squared is equal to S naught. So S naught is 0.8 times 20 seconds squared. All right. right, so that is 320 meters. So it's really, that's our initial position, 320 meters. So I think that's part A. And then part B says, what was its velocity at impact? So how would you do that? You would just find V of 20. All right, so we could have done that part first, but it'd be minus 1.6 times 20, right, which is minus 32 meters per second. And it makes sense that it's negative because it's going downward. All right. One more to go. So the next one's not really a free fall type problem, but we're using the same concepts of acceleration, velocity, and position. So number 73, I'll go ahead and bring the book into view here. Says, at the instant the traffic light turns green, a car that has been waiting at an intersection starts with a constant acceleration of 6 feet per second squared. At the same instant, a truck traveling with a constant velocity of 30 feet per second passes the car. How far beyond its starting point will the car pass the truck? How fast will the car be traveling when it passes the truck? Okay, so let's just make a little chart here. We've got the car and we've got the truck. So the car has an acceleration of 6. And then the velocity, we would integrate 6. So the velocity is 6t plus the initial velocity of the car, but it was stopped at the stoplight, so that's 0. Okay, the truck is the truck is traveling at a constant 30 feet per second. So it doesn't have an acceleration. So we just start with velocity. Velocity is equal to 30. We want to know, when are their positions equal? Okay, so S of t for the car would be 3t squared plus the initial position, but let's just call that 0 at the stoplight. And then S of t, all right, so how did I get that 3t squared? I integrated 6t, right? So that 3t squared came from integrating 6t. So sorry about forgetting that. So we have 30 dt, so that is 30t. So we could just set 3t squared equal to 30t to get the time for their positions to be equal. So we could say 3t squared minus 30t is equal to 0. You also might be able to just look at that and do it in your head, but let's factor out a 3t. We'd have t minus 10 is equal to 0. All right, so t is going to be 0, so at 0 seconds their position is equal, but that's not of interest, and 10 seconds. So 10 seconds is the key here. So how far, what's S of 10? You could plug it into either one, 3t squared or 30t. I think I'll do 30 times 10, which is 300 feet. So that's part A. And then part B, how fast will the car be traveling when it passes the truck? Well, that's 6. Our velocity at 10 is just 6 times 10, which would be 60 feet per second. All right, that does it for this video. I hope that helped, and I'll talk to you on the next lecture.